In this lesson, we'll talk about our last topic within chemical nomenclature, acid nomenclature. First of all, what are acids? In everyday life, acids are things that we encounter. They're not all dangerous. Of course, you hear acid, you think, oh, danger, which in many cases that is true. But in a more broad sense, it's any kind of a covalent compound that forms ions when dissolved. An ionic compound, of course, when it dissolves, already has pre-existing ions that would just break apart. But in a covalent compound that forms ions, those ions are formed de novo when they're dissolved. It almost always involves the hydrogen ion. We're going to talk a lot more about that in much later this year when we talk about acids and bases. But right now we are studying nomenclature, so we're going to tie in the acid nomenclature piece, and then we'll revisit this later next semester. Okay, how do we recognize an acid and distinguish it from other types of compounds? Acids always contain hydrogen. They always have an H. And they're always going to produce H plus ion, hydrogen ion, when they're dissolved. Chemists are typically nice to each other, and they'll begin the formula of a covalent compound with an H to signal the presence of an acid. So for our purposes, anytime you see a covalent compound, that means two or more nonmetals bonded together, whose formula begins with an H, you've got an acid on your hands. Here's the tricky part. When we name acids, we need to think about what is left after the H plus ion is removed from the compound. If you remove H plus, what's left behind is a negative ion. Remember, compounds are almost always neutral to begin with. So if you remove an H plus ion, what would be left behind is something with a minus ion. Here are some examples. If we have the acid HClO3, and I would know that it's an acid because hydrogen's a nonmetal, chlorine's a nonmetal, and oxygen is a nonmetal. And I would know that by virtue of their positions on the periodic table to the right side of the stair-step line. And I remove an H from that neutral compound, what I'm left with is ClO3 with a 1 minus charge after getting rid of H. Turns out that that's one of our polyatomic ions. If you consult your list of polyatomic ions, you would find this. It's called chlorate. Here's another example. HClO2. If you get rid of the H, you're left with ClO2 with a 1 minus charge. And again, that's on your list of polyatomic ions. That's chlorite ion. Or what if it's just plain HCl and you remove an H? You're left with Cl with a -1 charge. That is not polyatomic, but it's a normal monatomic, a single atom ion, chloride ion, which you could look up on your periodic table and see that since chlorine is in column 17, it would take a -1 charge. Our job is to think about the acid formula, mentally subtract an H plus, reduce the charge by 1, and then ask yourself what's left behind and can I name it? It's really important to name it. It's going to end with either an ate or an ite or an ide ending. So pay close attention to the ate, the ite, or the ide ending for the name of the negative ion, because that's going to determine how we handle the acid. Here are the rules. After we pay close attention to the ending of the name of the negative ion, if that negative ion ends with ate, then your acid name is, I'm writing blank here. That means it's something ic acid. We'll take the root of the name of the negative ion and plug it in the blank. I'll show you what I mean in a second here. If the negative ion name ends with ite, then the acid name is something OUS acid, something us acid. If the negative ion name ends with ide, then the acid name is hydro something ic acid. And you put that all together in one word. So let's return to those three negative ions we had identified earlier. HClO3, if you remove an H, the negative ion left behind is chlorate ion. So if we're following the acid naming rules, we would take the CHLOR, the part that comes before the 8 in the negative ion name, and put it in the blank for the acid name, CHLOR, and then ic acid. We pronounce that chloric acid. If the acid's original formula is HClO2, and you remove an H and identify chlorite ion left behind, then your acid name will be chlorus acid. If your acid originally has the formula HCl, you remove an H, you're left with chloride ion. Then your acid name is hydrochloric acid. Notice the root chlor appears throughout, since chlor is the root for all of these negative ions. There's a lot to remember here, students. Let's try to put that all together in the homework assignment. Good luck.